are you, my friends? In this video, I'm presenting 10 additional solved questions related to complex or compound fractions. They are really nice questions. Let's start directly. Question number 1 has 2 questions inside, parts 1 and 2. So I consider this 2 questions. Each one has a nice idea. Just read it and see, maybe you can try if you want from the beginning. Pause the video. This is very nice. We have negative power, negative power, negative power here. Then we start 1 over a squared, 1 over b squared, and this one we can invert the fraction, ab over 2 to the power minus 1, 2 over ab, and then we can do number 2 later. So number 1, after we invert, we use the negative exponents here, 1 over a squared, 1 over b squared, 2 over ab, 1 over b plus 1 over a. Now there are 2 methods, method number 1, method number 2, to simplify complex fraction. You can see that in the algebra course lectures 13 and 14. Now here I'm using method number 2, LCD for all fractions. So I see here 1, 2, 3, 4, 5 fractions. I find a squared, b squared, ab, ba. I need the LCD for all of them, a squared, b squared. Then I write the same question here, and then I multiply up and down by the LCD I found. Up and down, the same LCD. Now multiply this times this times that, this times this times this times this. Then the magic will come. What is the magic? No more fractions. No more fractions. All right, let's continue. So when we multiply this one by this one, we get b squared. See, this one, we cancel the a squared. Multiply this and this, you get a squared. Multiply 2 over ab times this, you get only 2ab. This one, you get b. You see, b is cancelled, so a squared b. And this one, a is cancelled, ab squared. Be careful here to get this one. Now we try to factor. We rearrange the first one. See, it's not arranged. So I can put a squared at the beginning, b squared at the end, 2ab in the middle. It becomes perfect square trinomial. This one I take ab, so I have a plus b. See, we can cancel one of the a plus b. The final answer, a plus b over ab. Really nice question. If you want, you can try this one. This one, completely different idea. We have x separate minus. This is a complex fraction, so we have to simplify that first. Then whatever the answer there, we say x minus the answer. Now I give you the idea. We can start here. This is question 1, part 2. Simplify second term. This one, second term. So this is the second term. I'm just stressing the idea here. Y over this. See, here I can add, you see, the LCD xy, multiply x and x up and down here. So get x squared. Here multiply y and y, you get y squared. Easy fractions. All right. So we have y over 1. You see, y over 1 divided by this one, x squared plus y squared over xy. Then I use the reciprocal here. I think we have seen many times the reciprocal. Y over 1 times the reciprocal. xy over x squared plus y squared. Now, I cannot cancel anything here. Y times y is y squared, and there is an x. And here, x squared plus y squared. So I leave that one, the second term. I put it here. Now, we continue the next slide. Remember, x minus the second term. Now, the LCD also x squared plus y squared. So the first one here, I wrote x over 1. Then I multiply by this. See, that's the difficult part here. X squared plus y squared up and down. I get this from the LCD now, because I need to make the same denominator here. So x squared plus y squared is the denominator here. X times the bracket, x squared plus y squared minus xy squared. Now this is x cubed plus xy squared, and there is a minus xy squared waiting, which would be cancelled. Final answer, x cubed over x squared plus y squared. Never think to cancel x squared here, never, because of the plus. Let's see more. This is more tough question. Now this is a complex number, which is too much complex. 1 over this, you see, you can just see it. You can just see. This is like a movie. 1 over 4 minus 3 over 2 plus x over 1 minus x. So I said in the question, this is like exam type. Make this complex fraction here, take it and change it to x plus a, there is a number a, x plus b. So make it simple like that. When you finish, take a, b, you add them. So you get some nice, easy number. Let's start. Very nice question, really. Start with the lower fractions here. See the 2 over 1. And now 1 minus x is the LCD. So I have to multiply up and down, only here, up and down by 1 minus x. So this will be 2 times 1, 2. 2 times minus x, minus 2x. Plus x becomes 2 minus x divided by 1 minus x. Still we have the 3, we have the 4, we have the 1. Now here we have 3 over 1. You see this is 3 over 1 like this. A over b, c over d. We call this RDF. Use the reciprocal when you divide fractions. So 3 over 1. You see I write here 3 over 1. I leave the 4. I don't touch it. So 3 over 1, sorry for this, 1 minus x over 2 minus x. So this will be numerator 3 minus 3x. Down we have only 2 minus x. Now this 4 over 1, I have to make it the same denominator. So I multiply up and down by 2 minus x. Maybe you can do this faster, some students. But here I did it in detail so that you can understand it. It's not an easy question. Now multiply the numerator here, only the numerator, because 4 over 1 here. 4 times 2, 8 minus 4x. And now we have the same denominator. You can pause the video and continue to see if you can get the correct answer. So that will be 8 minus 4x, and there is a minus. That's also a little trick here. So this minus will change. You see this minus here will change all the signs. Minus 3 minus 3x becomes plus 3x. So plus 3x, you see this plus 3x and minus 4x, that's minus x. 8 minus 3 is 5 over 2 minus x. Then we can use again RDF. So it will be 2 minus x over 1 over 1, 2 minus x over x, 5 minus x. But remember the given, I need x plus a over x plus b. So I multiply up and down by minus 1. Just to make the question, this is answer, correct answer, this is correct answer, this is correct answer. So 3 correct answers. But what I need, what is in the given? So I write x minus 2, x minus 5. That's correct answer. Now remember in the question, it says x plus a, x plus b. So I have to put the plus. To put the plus, then I put the minus in the bracket. So the a now is minus 2. The b is minus 5. It's not 2 and 5. That's wrong answer. Because in the question I said x plus the a, x plus the b. So the a and the b are the numbers after the plus. So the answer a plus b is minus 7. Really difficult question, but you can enjoy and do it 2 times, 3 times if you like. Let's see another more difficult. Don't tell anyone. 1 plus x squared all to the power half minus x squared, 1 plus x squared all to the power minus half, all divided by 1 plus x squared. Now there are 2 ways you can do this. See, we have here power minus half, power half. You can do factoring. We did many times factoring. You can go to lectures, algebra course in factoring. You can go to additional solved questions in factoring. You can factor. Or what I did here, I put the negative a to the power minus 1, 1 over a. Remember the negative rule. So I put this one here, 1 over. It looks complicated, but in one slide, one line and a half, I get the answer. See, x squared, I left it. This one, 1 plus x squared power half. Now, the big mistake students can do, you cannot distribute the power here. You cannot, because we have a plus. So this one, make the LCD, multiply here up and down by this one. Just remember simple example. Look at simple example here. If you have a minus x squared over a, oh, this is very nice example. Compare this with the yellow. A over 1, see, just look at the numerator here. This is a, same number. A over 1 minus x squared over a. The LCD will be, we write a, then here it will be a squared minus x squared. See, a squared, that means you multiply this and this. So when you add the power, half and half, you get 1. So it's only 1 plus x squared. Little tricky, minus x squared. To understand the yellow, what's happening, go to this and read it 2 times to understand. Now cancel the x squared. I have 1 over this, and this is 1 plus x squared over 1. It will be 1 over by the reciprocal. Remember this rule here. Multiply with the reciprocal when you divide fractions. So 1 times 1 is 1. Here we have the same base. You see 1 plus x squared. The power half, power 1. When you add, 3 over 2. Okay, now number 4 is medium question, but so nice, I think. Look at this. We need to simplify it. One good idea not to do, good idea not to do, do not multiply. Do not multiply, please. See, we can see common factor m squared minus 4 in all. So take it out. See, m squared minus 4, m squared minus 4, m squared minus 4. Take it common factor. Here, down, I will show you the answer now. Down we have 4 terms, mn, 2n, 2n, 4. So that means we have to use grouping. Go to algebra course lecture 12. Now, this is a common. Look at the numerator here. I put very nice example in the yellow stuff here. If you have y n squared minus 3ny plus 2y, what will happen here? You can easily, anyone can see there is a y common factor here. In the bracket, I will write n squared minus 3n plus 2. That's what's happening exactly here. If you put in your mind m squared minus 4 as y, you write it here. And then we have m squared minus 3n plus 2. Just try to understand what's in the yellow example here. Here we take the first 2 terms, take m common, minus 2, it will be n minus 2. Now we have n minus 2 common, also take it out. Inside we have m minus 2. So we cancel m minus 2, we cancel n minus 2, we left with m plus 2, n minus 1 is the final answer for this nice question number 4. Let's see number 5. We need to find only the least common denominator. I said just important. This is important because when you add, remember, when you add fractions or subtract fractions, whatever the fractions are, simple, medium, easy, difficult, challenging, you have to find the least common denominator, which means you have to make all the denominators the same. See, this is different, this is different. And you have to know how to do it. I explained that in the algebra course lectures, and I will explain it again here. This is the question, you see. The first step, factor each denominator. That's the step. Factor it. Don't expand. You see squared here? Don't say, I know the formula. X squared plus 4x plus 4. This one, I know the formula. Do not expand. You have to do the opposite here. X cubed minus 4x. Take x out, come on, see? x squared minus 4. 12, break it down. 4 times 3. 18, 9 times 2. This one already factored, leave it. Now, x squared minus 4, x minus 2, x plus 2. 4 make it 2 squared, 9 make it 3 squared. Leave it all power. Now we go. See, to find LCD, actually, 2 steps, believe it or not. Factor each denominator and then find it. Find it by what? The product of prime factors, each one raised to highest power. So I start number by number, 2 squared and 2, the highest power, 2 squared. 3 squared, I take 3 squared. There is x squared and x also. See x squared, the highest, only the highest. If you have x cubed, x squared, you take x cubed. Now let's look at the last one, x minus 2. X minus 2 is different number. X minus 2 cubed, I take x minus 2 cubed. X plus 2 squared, I take x plus 2 squared. Now, if you multiply everything here, this is 36, x squared, x plus 2 squared, x minus 2 cubed. What we call this? The least common denominator. You should be able to find the least common denominator for any set of fractions. Now, let's add and subtract here. The first one may be, I don't know, difficult. Let's see. The first one, 5 over this, plus. You see plus, and then we see minus 60 over this. The moment we see pluses and minuses, see, this is different. We have division here. We have pluses and minuses. Since we have division, we go in the brackets. I simplify this, I simplify this. Then I divide. Use the reciprocal. But here, the first one, completely pure, I have to find the least common denominator. I advise you, pause the video for 1 or 2 minutes at least, find the least common denominator here for these 3 fractions, and then we have to add them and subtract. Let's see, factor denominator first. You see the denominator, there's no space. Okay, so this is x plus 2, leave it. X squared minus 2x plus 4, I cannot factor. X cubed plus 8, there is a nice formula. Think you remember that formula in the factoring. X plus 2, x squared minus 2x, which is xy plus 4. Now, if you forget the formula, you have to go back and check the formula for factoring 2 terms. Okay. Now, let's make the same denominator. So the LCD, x plus 2, I take it 1 time. See this one here, x squared minus 2x plus 4, same power, I take it 1 time. So that's the LCD. See the last one here, I don't do anything in the last one, in the 60. See, I don't do anything. The LCD is there. This one, look at this one in the middle. X squared minus 2x plus 4. What is missing? X plus 2 from the LCD. So you see the nice colors here? Multiply up and down by x plus 2. The first one, we have already x plus 2. What's missing in this part? So now we have same LCD, same LCD, same LCD. But remember, you have to multiply on the top here in the numerator. Let's continue in the next slide. So I multiply 5 times this, 2 times that. Remember, there's a plus, there's a minus here. And now we have, look here, same LCD, same LCD, same LCD. So I write LCD 1 time. And then I expand here, 5x squared minus 10x plus 20 plus here 2x plus 4 minus 60. The squared, I leave 5x squared. I have minus 8x. And then 20 minus 60 minus 40 plus 4 is minus 36. I can factor this. Now to factor this is a trinomial. You can check algebra course on factoring 3 terms, because there is one lecture in factoring 2 terms, 1 lecture in factoring 3 terms, 1 lecture on factoring 4 terms. So when you factor this, you can use slide and divide. So you get x plus 2, there is x plus 2 here. You cancel. This is the final answer. Let me give you one quick important advice never multiply the LCD. Never. Do not spend second to multiply this down because you need to cancel at the end. Even if there is no cancellation, leave it. Do not multiply. Let's see question number 2. Oh, one slide. Question 6b, I hope you tried it. Okay, x squared over x plus 1, 1 minus x. You see here, I take LCD x minus 1, but I have to change this x minus 1. So I put here a minus. See, this is a plus. I took a minus, then it becomes here x minus 1, which is the same denominator. Always you can do that in math. If you have a minus b, put b minus a if you like, and then put a minus. If there is a minus from the question, it becomes plus. Now, this one is the same denominators. Let's concentrate on the first bracket here. This one only factoring, see, factor second bracket. This one we need LCD. So here there's LCD, there's division, and here we see only factoring. So this one becomes x squared minus 1, x minus 1, x plus 1. You see that? X plus 1, x minus 1 over x minus 1. Now, when you factor, this is the division, change it to multiplication. This becomes down, and this becomes up. So take 2. You see, take 2, it becomes x squared minus x plus 1. And here we take x4 plus x, take x cubed plus 1. Now, x cubed plus 1, there is a factoring, as I mentioned here, the formula is there. You see, I put the formula here, x cubed plus 1. So it's x plus 1, x squared minus x plus 1. You have to remember this formula for the cube. Also, there's another one for the minus. If you have a minus in the middle, this becomes minus, this becomes plus, and this is always plus. Now we start to cancel. All this bracket here cancels with each other. We are left with 2 over this, and this one, x minus 1 will cancel, x plus 1 will cancel. The final simple easy answer, 2 over x, for this big guy here. Very nice question. Question number 7. We have also 2 parts. We have negative powers. Now you know the story. Negative powers, directly we go to 1 over x squared, 1 over y squared, 1 over x, 1 over y. Then we have a complex fraction. So you can use method 1 or method 2. This is the same idea here. So maybe you can go a little quickly because I advise you to try number 1, also number 2. You can pause the video, try it. I will not see your answer, but you can check it directly here. So now 1 over x squared minus 1 over y squared, 1 over x plus 1 over y. I used method number 2. When you find the all fractions LCD, so this is x squared, y squared for all. Multiply up and down by x squared, y squared. This one times this one becomes y squared because we cancel. You know how to multiply. This one you cancel y squared, you get x squared. When you multiply here, you get x, y squared. When you multiply here, you cancel the y, x squared y. Now we factor more, 1 minus x, y minus x, y plus x. And now here we take a common factor, xy, cancel. This is the answer. The green one is the nice answer. Now, I wish you can try, this is very nice, number 2, because it's a little different from number 1. There is a little trick I have seen many times. Big mistakes some students, they do. I will tell you the big mistake that some students will do. See the power here, minus 3, right? You cannot write here 1 over BA cubed. Many students I have seen. 1 over BA cubed. Because the minus 3 only on the A, not on the B. Same here. Minus 3 on the B, not on the A. That's the only trick. Okay, 2 slides. So be careful. B over A cubed. That's the only trick in the question here. B over A cubed minus A over B cubed. 1 over b squared minus 1 over a squared. So now, the LCD for up in the numerator here is a cube b cube. See, I use now different method. This is method number 1 actually. If you do numerator and denominator, each one separate, then use the reciprocal here, that's method number 1. If you find the LCD for all fractions like this one, LCD for all fractions, this is method number 2. Any method you can like if you find it easy. Now this one, a cube b cube, so this one will be b4 minus a power 4, just adding by simple LCD. Add this one becomes a squared minus b squared over this. Use the reciprocal when you divide the fractions. So b4 minus a4 over a cube b cube times a squared b squared over a squared minus b squared. Now factor, 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 simplify, 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 find the answer, the correct final answer. Now, b4 minus a4, this is b squared plus a squared multiplied by b squared minus a squared. See this one here, a squared, we can factor this. But since we have the same up, there is no need to factor it. But you can, yes, I can tell you, yes, you can factor a minus b, a plus b, and also you can factor b minus a, b plus a. But since we have a square, so we can cancel. But remember, there is a little difference here. Remember this rule here in the yellow. X minus y over y minus x. In math, always that's minus 1. Again, if you have a minus b over b minus a, exactly like this, m minus n over n minus m equals minus 1. So I cancel this and this, I write minus. You see the minus in the answer here. A squared cancel with a cubed, I get 1a. Cancel b squared, I get 1b. Now look at the answer. You can write minus bracket, you see, minus bracket, this one over AB. That's correct answer. You can take the minus down here. You can put minus AB. And this one you can put a squared plus b squared. That's another nice answer. Correct. Now you can take the minus up without a bracket. You say minus a squared minus b squared over AB. That's another answer. So we call this in math, we play with the answer. You can change the form, all these same answer, but different forms. Well, the best one, I think, in the middle, or this, anyone you like. Anyone is the best. Okay, thank you for watching. And if you like the video, you can subscribe and share with your friends. I wish I can see you in another video with another topic. Thank you very much.